So today we're going to talk about systems of equations, basically just finding the variables for two equations or more. So another way to think of this is if we have two lines and we're trying to find the intersection of the two lines. So for example, we could have the two lines or two equations, y equals 2x minus 1 and y equals 3x plus 4, 3x plus 4. Oh, negative 3, sorry about that. Oh, wait, you didn't have to erase it.
Sorry.
Yeah, so the solution to the system of equations would just be whatever the x value is and whatever the y value is, or the intersection of the two lines. So we could kind of graph this out, like.
Okay, and so when David mentions the intersection is the x and y value that satisfies both of these equations. So if we have an x comma y, then the x comma y is a solution to the system of equations only if we replace x and y, both of these equations work. So
Yeah.
like,
And the ordered pair form is also how you would express the answer. So you wouldn't write it as like x equals 1 and y equals 2. You would actually write it as a point, so like 1, 2.
yeah. In this case, this point, it would be the x and y that would be the solution because it satisfies both of these equations.
Yeah. And this is obviously one of the ways to calculate the answers for a system of equations. You could just pull out your graphing calculator or pull out a piece of paper, graph the two lines, and then find where they intersect. But that's not very optimized. It's not very efficient. So we're going to talk about some algebraic methods. So we're going to talk about the first method, which is called substitution. So one of the things that we might notice is that the two equations equal the same value, which is y. So what we can do is that we could set the two equations equal to each other. So we could say 2x minus 1 is...
Plus one, I think.
Oh, yeah. Wait, it's minus 1. Wait.
No, it's plus one.
Wait a second. Okay,
It's
wait.
fine.
I
Both
think
of
I
them
said...
will work.
Yeah,
It's
both will
fine.
work.
It's fine.
Yeah, so if we have these two equations, we notice that they both have the same y variables, so we could set them equal to each other. So 2x plus 1 is equal to negative 3x plus 1. And here what we can do is that we can just isolate, basically just solve for the x variable. So we notice that it's 5x equals 0, and then x is equal to 0. And then to solve for the y value, what we can do now is that we could just choose a random equation from above. For example, y equals to 2x plus 1. And we just put the x value, which is 0, back into the equation, and we'll get the y. So we get y equals 2 times 0 plus 1. And that will mean y is equal to 1. So to express this answer, we will put it as an ordered pair. So it's 0, 1.
I think the one above is actually plus four, but
Yeah.
we can actually do another one. So 2x plus 1, y equals 2x plus 1, and y equals negative 3x plus 4. Essentially, it would be the same thing because they both equal to y. You can make them equal to each other and solve for x. 5x equals to 3. So x is 3 over 5, and y is 2 times 3 over 5 plus 1. You could also do negative 3 times 3 over 5 plus 4. Both of them will work. So the point right here would be 3 over 5, comma 11 over 5.
So we can try another example. We could have the two equations, the system 2x minus 3y is equal to 2.
What happened?
Oh. 2x
Oh.
plus, 2x minus 3y is equal to 2. Wait, negative 2, sorry about that. And 4x plus y is equal to 24. Now, for this one, it's not that nice as the other one where we already have the y's isolated, so we could just set them to each other. But in this case, we could just isolate the y for the second equation and put the second equation into the first equation. So we got y is equal to 24 minus 4x. And now what we can do is that we can either try to isolate the y in the first equation, or we could put this second equation as a replacement for the y. So we can rewrite it as 2x minus 3 times 24 minus 4x is equal to negative 2. And we could just solve for this. 2x minus, yeah, too fast for me.
Am I doing it right?
Yeah, I think you did it right. And we
So
could just,
when you solve for y, just plug the x back in.
and we should do another example, but we'll leave it to you guys. So we can have the system 4x minus 2y is equal to 2. And 2x plus y is equal to negative 5.
Since no one is responding, should we just do this one and give them another example?
Yeah, we should.
Yeah, because I think some people might be confused right now.
Yes.
So firstly, what we want to do is we want to isolate the y. In this case, it would be easier to isolate the y in the second equation because the coefficient of y is 1. You don't have to divide everything by the coefficient of y. So in this case, we move the 2x over and we get y equals to negative 2x minus 5. Then what we want to do is we want to substitute the y back into the other equation in terms of x. So in this case, we have 4x minus 2 negative 2x minus 5 equals 2. And what this does is it will make a single equation with only one variable. So now it's pretty easy to solve for x because we only have one variable. 4x plus 4x plus 10 is 2. 8x is negative 8, so x is negative 1. Now that we have one variable, we can solve for the other one. So y is negative 2 times negative 1 minus 5, which is 7. So the solution would be negative 1 comma 7. Does that kind of make sense, or is anyone still confused? Okay, we'll take silence as everyone is good. Should we give them another example to try?
Sure. Should I give out this interesting one?
Wait, Edward asked if I'm sure if it's correct. Oh, that does not look correct. Let's see.
Oh yeah, it's not 7.
Oh, it's
Yeah.
3. Sorry, yeah, the
Yeah.
last step. So if you want to check your answers, just plug x and y back in. So 4 times -1 minus 2 times 3. Is this equal to 2? Yes, it is. Now for the second equation, 2 times -1 plus 3 equals 5. Is this equal to 5? The answer is yes. So the solution would indeed be -1, 3. Okay. Should we give them an example to try?
Sure.
Okay.
Wait, do you want like a working one or one that's should we talk about when the lines are parallel because there's an example in here?
Oh, I think we should just give a solvable one.
Okay. Yeah, we can have the system 2x plus y minus 4 is equal to 0. And then we have 3 times x plus 3. It's in brackets x plus 3. It's a binomial for some reason. Don't know why. Oh, no, the x plus 3, not the 3 part.
Oh, okay.
Yeah, and then minus 3y is equal to 7.
David, is that right?
I think that's correct, but I don't have the answer, so we'll do it as a class and figure it out.
Okay.
Yes.
Yeah, that's correct.
Yeah.
Because yeah. Okay, nice. Do you want to explain it?
Yeah, sure. Okay. So here it's kind of easier to isolate the y in the first equation because there's less stuff going on. So we can isolate that and we get y equals to negative 2x plus 4. And then here we go substitute it into the second equation. And we get negative 3 times x plus 3 minus negative 2x plus 4. And we get 3x plus 9 plus 2x minus 4 equals 7. And here we get 5x is equal to, 2. And then we get x is equal to 2 over 5. So the x is correct. And y is equal to negative 2. Oh, negative 2 times, 2 over x. Oh, wait.
2
which
over
equation?
5.
Yeah, 2 over 5 plus, Oh, you already isolated the y. Okay.
Yeah, because it's here.
Yeah, negative 4 over 5 plus 4. Yeah, so that's correct.
Yep. And in some cases, if it's easier to isolate the x, you could also isolate the x. But usually it's in the for you isolate the y. Okay. We should do the parallel one now.
Oh yeah, okay. So we can have the system 7x plus 2y is equal to 16. And negative 21x minus 6x plus 24 is equal to, equal to 24. Wait,
Oh,
yeah,
equal
I
to
read it
24.
wrong. Sorry
Okay.
about that.
That's all good. Are you sure? Wait, isn't it negative 24?
It says positive 24. I have no idea.
No, it should be negative 24.
Huh, okay.
Yeah. Okay. Do you want to explain it?
Yeah, sure. Okay, so there's not a really easy way to do this, but we can kind
Wait.
of do it for the first one. Wait, minus 4, okay.
Equals negative. It doesn't matter what the last term is.
Yeah. So let's do this a naive way, I guess.
Yes.
Okay, so what we can do is that we can try to find a variable that's easier to isolate because there's not really a good one. So maybe we can try the first one, try to isolate the y in the first one. So we get, yeah, this is not going to end up nice.
So we get like
No, y is
this.
equal to, yeah, we get that. We could try to substitute it back in there. Yeah, 6 times, yeah. Negative 24, and then negative 21. Oh my gosh.
Is this like negative 48, I believe?
I have no idea at this point. So not good numbers.
Yeah.
Yeah, okay. I think you did that right.
Okay, so this would be an example of no solutions actually.
Yeah,
But
the 21x and the negative 21x cancels out, and this statement just doesn't make any sense.
yeah, so if we do everything correctly and we get to something that like that does not make sense at all, like negative 48 equals negative 24, then that means that there are actually no solutions to the equation, to the system of equations. What this will look like on graph is that these two equations are parallel lines. So for example, they could be like this. Since they're parallel, then that means there are never an intersection point between these two lines, which means that an answer does not exist. So if there's never an intersection, then there's also never a solution. Should we give them like an infinite solution one?
Yeah, sure. 2x plus 2y is equal to 3. And 2y is equal to 3 minus 2x. Wow, I wonder what that's going to give.
Okay, I guess I can explain this one.
Yes.
So if we just isolate the first equation, we get y is 3 minus 2x all over 2. And now, just like usual, we plug it in to the second equation. So we get 2x over 2. If we extend it out, we get 3 minus 2x is equal to 3 minus 2x. In other words, 0 equals 0. If we do everything correctly and we end up with something that's always true, like 0 is 0 or like 2 is 2 or x is x, then that means there are infinite solutions to this system of equations. What this would look like on a graph is that they're basically the same line. So one line is like this, and then another line is the same line. Since they intersect at infinite many amount of points, there are also infinite many of solutions. Now, this does not mean that every number in the universe is a solution. Only x and y values on this line is a solution. So some things to note. All x, y are not solutions. There are only an infinite number of solutions. So for example, a point here would not be a solution, but any point along this line would be a solution. Okay, does that kind of make sense? Hopefully. Okay,
We're
cool.
gonna assume that's a yes.
That's a yes, cool.
Okay. So actually, we should move on to the second method.
Oh yeah, the elimination one.
Yeah, okay.
Okay.
So we're gonna move on to the second method, which is called elimination. So as you might have noticed before with the substitution, we kind of ended up with a lot of ugly fractions if the equations don't work out nice. So for example, if we have the system of equations 2y is equal to 5x plus 1, and 4y is equal to 3x plus 9, we can see that there's no really good way to isolate y or x. You're going to end up with not pretty fractions. That's not going to be nice to work with. So what we can do is that we can use elimination. So it's kind of like if you were just doing addition and subtraction, but in this case, you're just adding and subtracting equations. So what we do here is that we multiply the first equation by the number 2. So we just multiply every term in the equation with the number 2. So we get 4y is equal to 10x plus 2. And here what we notice is that the second equation and now the multiplied by 2 first equation both share 4y. So we can obviously kind of substitute it, but what else we can do is that we can just quote unquote subtract the two equations. So we could emulate a subtraction. So we could subtract it, put a bar like subtraction. We get 4y minus 4y is equal to 0, 10x minus 3x is equal to 7x, and 2 minus 9 is equal to negative 7. So here we kind of got a third equation where it's just the x. So we can just solve for x and we get x equals 1. And then what we can do is that we can just do what we did before with substitution and put the x back into one of the equations and just get the y.
Yeah, so does anyone have a question on why we multiplied the first equation by 2 and not any other numbers? Okay, this is because we want to eliminate the number of y, the y variable in these two equations. How we do it is by matching the number of y's in the first equation and the number of y's in the second equation. So we multiply by 2, so we get the same coefficient on y, and then we can just subtract it to eliminate the variable.
Yeah, so do note that it doesn't have to be the y's that you're eliminating, but just pick something that'll work out nice, because in this case, we could have also done it with the x's, but we would have ended up with 15x and some quite big constants. So we just did 4y because it's the easiest.
Well, we can also try like doing x if you want to.
Yeah, we can do that.
Okay.
So our goal is to cancel them out. So we got to make them equal. So we can multiply the first equation by 3 and the second equation by 5. So we both get 15x. 6y is equal to 15x plus 3. And 20y is equal to 15x plus 45. And here we can cancel out the x's, again by subtracting. Oh, I don't think it's 2.
Yeah, 5.
So we can subtract, and we get negative 14y is equal to negative 42. So we can do y is equal to 3. So we can also see that this is the right answer.
I guess I can just write it down. Eliminate dy. Eliminate x. Okay.
Yeah, so we can do another example. We can do 2x plus y is equal to 10. And 2y minus 2x is equal to 5. So to make this a little easier, what we can do is that we can kind of rearrange the variables so they line up. So we could rearrange the first or second equation so the x's and the y's line up. It kind of makes it easier. Yeah, we can get 2x plus y is equal to 10 and negative 2x plus 2y is equal to 5. And here what we notice is that we can either multiply the y in the first equation by 2 to cancel out the 2 y's, or we can notice that we got 2x and negative 2x, and if we know a little bit of addition, we can see that when we add those two things together, we get 0, so we could just add instead. Technically, you can do this with almost every operator, I believe. Kevin can confirm that.
Yeah, you can do it with everything.
Yeah, so
Actually, it's a bit risky to do a multiplication and division, but
yeah,
like because if you multiply it, you still have x and y. It won't get you anywhere. So
just stick with addition and subtraction. They'll like
yeah,
carry most of the equations. So
yeah, exactly. Can you confirm my answer, David?
I think that is correct.
Okay, awesome. Yeah, that looks correct.
Okay, should we do another example?
Yeah.
Okay, we can have 4x plus 3y is equal to 32. And 2x minus 7y is equal to negative 18. Should we do this one together?
Do you guys feel confident doing this on your own? Because we can do another example if any of you guys are confused. You know what? We should just do this like all together.
Okay, so should I explain this one?
Yeah, go for it.
Okay, so in this case, if we try to multiply the y's, it's not going to work out that well, but the x's are going to be pretty well, so we can multiply the second equation by 2, so we both get 4x's minus 14y is equal to negative 36, and then in this case, we just subtract the two equations. So get 0x plus 17y equal to 68. Okay, that's not too nice, but oh wait, yeah, it works out nice. Okay, I'm dumb.
Yeah.
And then we could put it back in. We get x is equal to 5. Okay.
I guess the biggest thing the biggest mistake that new learners make is that they forget to multiply everything by 2. So they could maybe turn this equation into something like 4x minus 14y is negative 18. And this would be wrong because you have to multiply everything, including negative 18 by 2. So when you're multiplying an equation, you have to do it to every single term in the equation. Okay. Now we can give an example for them to try.
Yeah. Okay, let's have an easier one. So we can have the system of equations 3x plus y is equal to 26. And x plus y is equal to 18. Yes, Edward, that is correct. Also, can you scroll up?
Like here? Okay. Right. You can go for it, David.
Okay, so in this case, we could have done substitution, but since we're doing elimination, we're going to do that instead. So here we notice that we technically don't need to multiply by anything because there's one y in both of the equations, so we can just subtract. So we get 2x is equal to 8, and that would mean x is equal to 4, and we could put the x back into the equation and get y is equal to 14.
Should we do another one?
Yep, we can.
Okay.
We can do x plus 8y is equal to 15. And negative x negative 10y is equal to negative 19. Yeah, subtract 10y. Edward, that is correct.
Yep.
Okay, let's go through it together. Okay, so here we notice that we have that x and negative x, so the reciprocal, well, not the reciprocal, sorry, the inverse. So what we can do is that we could just add the two equations to cancel it out. So we get 0x plus, subtract 2y is equal to negative 4. And y is equal to 2. And we could put it back in. We get x is equal to negative 1.
So I think that's correct.
Yeah, I think that's correct.
Okay.
Yeah.
All right. David, are we gonna do like a system of 3 equations right now, or?
They have a 3 equation example, so let's just do it.
Okay.
Okay, we should do it as a class.
Oh yeah, for sure.
It's gonna get complicated. Okay, so we have the system x plus 2y minus z is equal to 4. And we have 2x plus y plus z is equal to negative 2. And we have x plus 2y plus z is equal to 2. Okay, now we
Okay.
gotta solve for all 3 variables.
I mean, in the sense, if we were to plot it out, graph it out, it would actually be in a 3-dimensional plane. So think of this side as going out of the page, going towards you guys, and this one going into the page, right? So when we plug them out, we have something that looks like, I don't know, like this. This point right here would be the solution to the system of 3 equations. So we will have x, y, and z instead of just x and y. I just want to like share that with you guys. Okay, now let's solve it.
Yeah, so to solve it, we don't have to solve it all at once. What we can do is that we could split it into a bunch of 2 equation parts. So what we can do is that we can try first solving the first 2 equations. Oh, we can label it actually.
Yeah.
Yeah, 1, 2, and 3. This helps just to organize it. So we can say is that we have 1 plus 2. Then we have x plus 2y minus z is equal to 4 plus 2x plus y plus z is equal to negative 2. And here we can just add both of them together to cancel out the z, and we get plus 3y is equal to 2. And then here we got a 2-variable equation. And now what we can do is that we can also do the same thing with the equations 2 and 3, or 1 and 3 actually. So
Let's do 2 and 3.
okay, 2 and 3. Yeah, 2 minus 3. And we get 2x plus y plus z is equal to negative 2. Subtract x plus 2y plus z equal to 2. Oh
Yeah,
boy.
so the reason we're doing minus is we want to isolate one variable, and in this case, we want to isolate the z or z. So for 2 and 3, we want to minus 3 from 2 to get rid of the z. What if there's 4? If there's 4, I guess you take the first and second one, first and third one, first and fourth one to get a system of 3 equations, and then you would do the same thing and get a system of 2 equations, and finally you'll get a system of 1 equation.
Oh, just don't do it graphically.
Yes, 4-dimensional plane. That'd be fun.
Yes.
Uh,
Yeah, so we just subtract these two equations and we get x subtract y is equal to negative 4. And then here we see that we have two variable equations, so we can label them as 4 and 5. And then what we can do is that we could solve both of these. So we have 3x plus 3y is equal to 2, and x minus y is equal to negative 4. And then here we can multiply the second equation by 3.
oh, second
Oh,
one, right?
yeah.
Yeah, second one. Oops.
I get 3x minus 3y is equal to negative 12. And then you could subtract it, but in this case, we're just going to add it to cancel out the y's. So we get 6x is equal to negative 10, and x is equal to negative 10 over 6. Yeah, negative
Or
5 over 3.
5 over 3.
Yeah, that's not very nice, but... So since we have the x now, we can technically just substitute it back into one of the previous 2-variable equations. So for example, equation 4 or 5 to get the y value.
Yeah, so it'll be negative 7 over 3, I'm guessing.
Yeah.
X minus... Wait, that doesn't look good.
Wait, negative 5 over 3 minus y is equal to negative 4.
It should be plus positive 7 over 3, I think.
Yeah, positive 7 over 3. Okay, yeah,
Wait,
I think that's right.
21 negative. Okay, yeah, that's right.
Yeah, that's right. And then since we have two equations, what we can do is now we can substitute these two values back into the 3-variable equations. For example, equation number 3.
So
oh gosh.
X plus 2y plus z is what?
2, I believe.
Yeah, 2.
2. So we get negative 5 over 3 plus 14 over 3 plus z is equal to 2. And then here we have wait. Okay,
Well,
my
the
mind
left
is
is
blanking
just
out. 9
3.
over, yeah, just 3.
Yeah.
3 plus z, oh yeah, 3 plus z is equal to 2. So that would mean z is equal to negative 1. So we have a 3-dimensional coordinate now.
On the plane, it would look something like this is the x, this is the y, and this is a z. So it would be something right here, going back into the plane. Okay.
Yeah. And I think 3 equations in a system is like the most you'll get in Math 10. That's what my teacher did.
Yeah.
Yeah.
I mean, honestly, I get it. It's really hard to do it with 3 equations, but like as long as you like try some things out, just try random combinations, you'll eventually end up with a system of 2 equations, and that's easier to do.
Yeah. Just whatever next step you're gonna take, at least try to cancel out one variable.
Yeah, that's the entire point of like solving 3 equations.
As long as you're canceling a variable out, you're doing the right thing.
Yeah. I can write it up here. So the first step is to cancel out a variable. The second step is to cancel out a variable. So now you're left with one variable, and so the third step is to just plug in the known variables. Okay.
You know, I just realized there was actually a faster way to do this system of equations.
There is.
We could have subtracted the first and the third equation.
Oh yeah,
Yeah.
that's true.
Here, actually, let's talk about that. Okay, so in the first and third equations, they both have basically the part x plus 2y. So what we could have done is that we could have subtracted these 2 equations and just ended up with negative 2z is equal to 2, I think. Yeah.
Yeah.
Yeah, and that actually would have sped it up a lot.
Well, not really, because when you have -1, you still have a system of 2 equations. So
Yeah, that's actually true.
yeah, just okay. The key takeaway here is to just try different combinations. As long as you're getting a system of 2 equations, you're doing everything fine.
Okay, should we do a word problem? Because that's also something you might encounter.
Reading comprehension, sure.
What? Okay. Yeah, so you might have seen a lot of like word problems with like system of equations. For example, let's give one random one out right now. Okay, so for example, if Kevin went into a superstore and he bought 3 pencils and 5 erasers for the extremely overpriced amount of $62.50.
Give me 1 second.
Yes.
3 pencils and what?
3 pencils and 5 erasers for the price of $62.50. Those are gold covered erasers.
That's expensive.
Yeah. And then I go in there and I buy 3 pencils and 2 erasers for $52. So this word problem would be the system of equations, and you're going to have to solve for 2 of the unknown amounts. Yeah, 1 pencil and 1 eraser, or like 1 pencil and 2 erasers.
1 eraser.
Okay.
Actually, just find the price of a pencil and find the price of an eraser.
Yeah. Andrew just said bruh in chat.
Bruh.
Yes.
We could also do like the chicken and the duck problem. Like,
Oh my
you know that
gosh.
problem? Like the how many number of heads, how many number of legs?
Oh yeah. Oh yeah, okay, that works, but I don't have an example for that. So if you know one.
Yeah, I can give one. It's easy. I think
Okay.
it's called 鸡兔成龙 or something.
Okay. Let's solve this problem first.
Yes. Solve this one.
This word problem kind of literally tells you the equations where we have like, for example, we have let x be the number, the cost of pencils. Okay, I think Edward already solved it.
Oh wow.
Okay. Well, let's just go through this anyways.
I think
Yeah.
give me a sec.
Yeah. Now convert
Oh
that
yeah,
into
that's right.
USD.
Yes, that's right. USD.
Yeah, okay. We can define some variables first, so we can be like let x or like let p is equal to the price of a pencil.
Yes, definitely. Okay, for every single word problem, you have to list your variables, or your teacher is gonna like credit like subtract a point or something.
And then we can have let e is equal to the price of eraser. And then what we can do is that we can just literally copy line by line the word problem. So we have 3p. Oh, okay. We can have 3p plus 5e is equal to 62.5. And their second equation would be 3p plus 2e is equal to 52. And then here we could just use elimination and we could just subtract and we cancel out the p. So we get 3e is equal to 10.5.
Why is my like thing so tilted?
Uh-oh.
Okay, yeah.
Yeah, we can just subtract. 3 is equal to 10,
Oh,
10.5.
10.5.
Yeah. And then we can see that e is equal to 3.5. And then here we can just substitute it back in and get the value for p. Yeah, so some quite expensive pencils right there.
Yes.
Yeah, and depending on the question, they might not ask you for the price, but maybe they're like asking you for the price of a different combination. But since you have the price, that's pretty easy to do, so we're just not going to talk about it.
Yeah. So okay. Like what David said, or what I said before, the first step is to list your variables. Second step is to solve and like make the equation, solve and make the equations. Okay, why can't I spell solve? And the third step is to like write your answer in the sentence.
I mean, I don't think you really is required to write in a sentence. Some teachers might be a little more lenient with that, so but just write it down anyways. It can be like a really short sentence. Pencil
Yeah.
price is equal to 15. Eraser price is $3.50.
I don't know about your teacher, but my teacher, like, her mark breakdown is basically 1 point, 2 points, and like 1 point. So you have to do
Oh.
all of these steps to get full marks. Just as a quick math tip. Okay, should we do like the rabbit and the chicken problem?
Yeah, we can do that.
Okay. So in a farm, there are 5. Okay. There are a number of rabbits and chickens. In total, there are 5 heads and 14 legs. How many chickens and rabbits are there? So just as a reminder, a chicken has 2 legs and a rabbit has 4 legs.
Yeah, if you like don't know that, somehow be sure to ask your teacher.
Yes.
It's a 10 out of 10 drawings right there.
Yes.
What if they're amputated?
Uh,
I think the teacher will
huh.
make that clear.
Interesting. Oh, 2 rabbit and 3 chicken. Yeah, exactly. Good job. David, do you want to explain it?
Yeah, sure. Okay, so the first things before anything, define some variables. You could say, let R is equal to the number of rabbits. Yes, assume healthy full-limbed animals. Yes. And C could be equal to the number of chickens. So what we can do is that we could say R plus C is equal to 5, because hopefully they have one head each, or else we might be in like Chernobyl or something, and I don't think that'll be a great math problem. And then
Facts.
we also have, and then we yes, and then we also have 4R, because each 4 legs for each rabbit and 2 legs for each chicken is equal to 14. So to solve this system, yes, heads, legs. And then
How
what
do we
we can
solve
do
it,
is
David?
let's use elimination.
Okay.
So we can multiply the first equation by 2, so we can cancel out the chickens. 4R. Oh, is your Apple Pen not doing well again?
What?
Oh, nothing.
I can write.
Okay, it's good. Wait, okay, now let's subtract the 2 equations. So when we subtract, we get negative 2R is equal to negative 4. So it's just 2R is equal to 4. And there's 2 rabbits. And then we could plug it back.
Wait, give me a second.
Uh-oh.
Can you still hear me, David?
Yeah, I can still hear you.
Sorry, my AirPods died for some reason. Okay.
Oh, okay. Okay, and then we could put this the value R back into the first equation, and we could see that there's 3 chickens.
3 chickens? Yeah. Okay. All right. Should we give like one more example?
Yeah, I think we should.
Okay, we have 4 minutes.
Huh, okay, wait. There's this interesting one on the worksheets. Should we do it?
Worksheets?
Yeah, do you want to move? Yeah. I think it's number 12.
Like the sum of. Oh, okay.
Yeah.
All right. Oh, yeah. That's I love those. Should we solve it together or let them try?
What do you feel like?
Depends on you. We should just let them try, honestly.
Yes. Oh yeah, and then there's also that distance, speed, time thing.
Oh, those ones are hard.
Yeah. Yeah.
Let's do 12 first.
Yes.
38. Is that correct, David? I'm not sure.
I'm not sure either. Let me check the answer key.
Wait, no, but we can just
Yeah, it's
83
correct.
minus 38. Yeah, that's 45.
Yes.
So that's great. Yeah, good job. I guess we could speedrun this.
Yes, we can. Okay, so we can define some variables. X is a digit in the tens place, and then y is equal to, yeah, the second digit. And then x plus y is equal to 11.
So this would be the number. X plus y is 11.
Yep. And then wait, what is it? 45 more. So we get 10y plus x is equal to 45 plus 10x plus y. I think that's the right equation.
Yep.
Okay. And then we can solve this. Move everything to one side, I guess.
Yeah,
What do we
if you're just curious, like, or confused, this is just yx, and this would be xy. Okay.
So we get 9y minus 9x is equal to 45. Then we could just divide out the 45.
Yeah.
Y minus x is equal to 5. And then we can add the two equations to cancel out the x, and we get 2y is equal to 16. And then we get y is equal to 8, and x is equal to 3. So if we combine them back together, we get 38.
Double check. 83 minus 38 is 45, and 3 plus 8 is 11. So we got it right. Alright, is that all
Yes.
for this lesson?
Yep, I think that is all.
Okay. Well, thank you guys so much for coming today. It was fun to teach. Hope you guys learned something new.